Welcome to aminacademy.com. In chemistry, let us discuss about characteristics properties of gases. Gases have three characteristics properties. They are easy to compress, they are expand to fill their containers, and they occupy far more space than the liquids or solids from which they form. An internal combustion engine provides a good example of this, the ease with which gases can be compressed. Here, properties of gases we will discuss further. Each state of matter has its own properties. Gases have unique properties because the distance between the particles of a gas is much greater than the distance between the particles of a liquid or solid. Although liquid and solids seem very different from each other, both have small intermolecular distances. Gas particles, however, are much farther apart from each other than liquid and solid particles are. In some ways, gases behave like liquids. In other ways, they have unique properties. Gas or fluids. Here, gases are considered fluids. People often use the word fluid to mean liquid. However, the word fluid actually means any substance that can flow. Gases are fluids because they are able to flow. Gas particles can flow because they are relatively far apart and therefore are able to move past each other easily. Next, gases have low density. We'll discuss this. Gases have much lower densities than liquids and solids do because of the relatively large distances between the gas particles. Most of the volumes occupied by a gas is empty space. Particles in a solid or liquids are almost in contact with each other, but gas particles are much further apart. This distance between particles shows why a substance in the liquid or solid state always has much greater density than the same substance in the gaseous state does. The low density of gas also means that gas particles travels relatively long distance before colliding with each other. Gases have gases are highly compressible. Suppose you completely fill a syringe with liquid or try to push the plunger in when the opening is plugged. You cannot make the escape. The liquid takes by some become smaller. It takes very great pressure to reduce the volume of a liquid or solid. However, if only gas in the syringe with a little effort, you can move the plunger down and compress the gas. Gas particles can be pushed closer together. The space occupied by the gas particles themselves is very small compared with the total volume of the gas. Therefore, applying a small pressure will move the gas particles closer together and will decrease the volume. Next, or gases are completely filled in a container. Suppose even small amount of gas, if you fill a container, it occupies full volume. A solid has a certain shape and volume. A liquid has a certain volume but takes the shape of the lower part of the container. In contrast, a gas completely fills in the container. One of the containers contains a gas and other containers is empty. For example, when the barrier between the two containers is removed, the gas rushed into the empty container until it fills both containers equally. That means valve is open or supposed to container connect with the pipe with valve. If one side is filled with gas, other side is empty. If you open a valve, what happened? The gas rush to the second container and the pressure become equal everywhere. Gas particles are constantly moving at a high speed and are far apart enough that they do not attract each other as much as particle in solid or liquid do. Therefore, a gas it expands to fill the entire volume available. Next, we will discuss about gas pressure. A gas pressure is caused by the force exerted by a gas molecules colliding with the surface of object. Although the force of each collision is very small, any surface of appreciable area experiences a large number of collisions in a short time, which can result in a high pressure. Suppose if you compressed, the pressure become more. Now, measuring pressure is an important part of the lesson here. Gas pressure, gases are all around us. Earth's atmosphere, commonly known as air, is a mixture of gases, mainly nitrogen and oxygen. Because you cannot always feel air, you may have through of gas or being weightless, but all gases have mass. Therefore, they have weight in a gravitational field. If gas molecules are pulled towards the surface of the air, they collide with each other and with the surface of earth more often. Measuring pressure. A manometer is a device to a barometer that can be used to measure the pressure of a gas trapped in a container. A closed end manometer U-shaped tube with one closed arm and one arm that connects to the gas to the measured, and a non-volatile liquid, usually mercury, is between. Here, U-tube is there in which some part of the space is filled with liquid, non-volatile, and one side is pressure is connected, container is connected, so it pushes the liquid, that is mercury, and come up. Here the difference between the height is the pressure on the container. Even pressure gauge also useful. In scientific definitions, a pressure is the force divided by area. To find pressure, you need to know the force and the area over which that force is exerted. Here, that unit of the pressure is commonly Pascal, which is equal to Newton per meter square. That is force by area, kg per ms square. A Pascal is a standard unit of pressure. A Pascal is very small amount of pressure, so that most useful unit for everyday gas pressure is the kilopascal, because Pascal is very less unit, smaller unit, so we are using kilopascal normally, kPa. The kilopascal is equal to 1000 pascals. Another commonly used unit of pressure is the atmospheric pressure, atm. Now we'll here this table is important. That means what is relation between the units of different units of the pressure. Look at here. 1 Pascal is in terms of bar is 0.00001 pounds per square inch. Your conversion is there. This is more useful. This conversion table is more useful to calculate pressure in different units. Atmospheric pressure can be measured by a barometer, as shown. You know that barometer. This pressure goes through the fluid and up the column of the mercury. The mercury settles at a point where the pressure exerted downward by its weight equal to the pressure exerted by the atmosphere. Barometer is a useful equipment to measure the atmospheric pressure. At sea level, the atmosphere keeps the mercury in a barometer at an average height of 760 mm, which is 1 atmosphere. Therefore, 1 atmospheric pressure is equivalent to 760 mm of the mercury level. 1 millimeter of mercury is also called a torr. That is Torricelli, after Torricelli, the Italian physicist who invented the barometer. Other units of pressure is given, is tabulated. It's very useful. table, we have to remember the conversion factor for units of the pressure unit of different standards. We have done. Please subscribe our YouTube channel. Before that, we'll do some small example problem to conversion of pressure. Look at here. Now, convert 1 atmosphere 1 atm 1 atmospheric pressure, that is equal 101.325 Pascal. Therefore, 1 mm of Hg from the table we are doing equal 133.322. Pascal. Therefore, you convert 1 atmosphere in Hg of mercury you can do, which is equal 1 into 101.325 into 1 into 1 mm of Hg over 133.322 Pascal, which is equal 760 mm of Hg. That means 1 atmosphere is equal to 760 mm of Hg. In further videos, we'll discuss more about gases. We have done. Please subscribe our YouTube channel.